It says right here, this is the main topic of today. Angle 5 and angle 7 are vertical angles. So we're talking about this angle right here and this angle right here. They are vertical angles. It wants you to prove that angle 5 and angle 7 are congruent to each other. Now, no matter what happens, what do you know is going to happen at the end of this proof? So what am I trying to tell you? The main point of today is vertical angles are congruent. Vertical angles are the exact same size. And we talked about that a little while ago when we talked about adjacent, linear pair, supplementary, complementary vertical angles. Vertical angles are equal, congruent. They are the same thing. So now we have to just say why that's always true. And there's like one, maybe two questions on your test that has to do with the math behind this. Not a proof, just the algebra part. So I have to drive this to where you guys can understand it. Do you like simple statements or do you like long and complex statements? Okay, so we're going to do this, the simple statements. It's going to make the proof just a little bit longer, but it's not a big deal. All right, so what is always our first statement?
Given.
The given part. So the first statement, Tim, not the first reason.
Oh, my bad.
The first statement is what is given. Angle 5 and angle 7 are vertical angles. And I'm going to abbreviate so everything fits. Vertical angles. And you guys have like a super microscopic copy of this. Angle 5 and angle 7 are vertical angles. And Tim stated that is true. Why is that true? Okay. At this point in the proof, you're looking at the picture and you're trying to say what you see in math terms. Say what you see. So can you use some math words and describe what you see? Okay, I like the word acute. It's a good push in the right direction, but there's a different word. So can we just use 5 and 7? Are 5 and 7 connected somehow?
Yeah.
They're connected by what angle? Angle 6. So what can we say about angle 5 and angle 6? Some sort of math word. They are side by side. They're adjacent. We have a very special word for that. It's a pair of angles that make a. What do you call a pair of angles that make a line? Right? A pair of angles that make a line is called a linear pair. Right? Do you think that 5 and 7, 5 and 6 are a linear pair? Huh? Are 5 and 6 a pair of angles that make a line?
Yeah.
Yes. Now, don't write that down because that's not really important. What do you know about linear pairs? What do you know about linear pairs? So mathematically, what do you know about them? They're not the same. Okay, how many degrees are in a line? What do you call a pair of angles that make 180 degrees? Supplementary. Okay, so our second statement. Angle 5 and angle 6 are supplementary.
What is the test for this again?
Thursday. Alright, and why do we know that they're supplementary? But why are they equal 180? because they're a linear pair. So we know that they are supplementary because you can do it, little buddy.
You might have to click them up,
Just go to the floor.
No. The
It's
button's
yeah,
broken.
it's not like the mouse button.
I know well, there's a secondary button on here that is like a right click, and that one's broken. All right, we know that they're supplementary because
on the mouse
they are or we put that the definition of a linear pair. So if 5 and 6 are supplementary because they're a linear pair, 6 and 7 are supplementary for the exact same reason. You said you guys like simple statements. Now, if you're an advanced thinker, you could have wrote all of that for just statement 2. So you said statement 2 and not made it 2 steps. Okay, you don't have to. Does that make sense? All right. So we know that 5 and 6 are supplementary because they're a linear pair. And that should help you think of something else. Now that you know that they're supplementary, you should be able to think that they equal 180. So what equals 180? Which two angles equal 180? So I should write that down. I should say angle 5, what is going on here? Plus angle 6 equal 180. Well, how do I know that they add up to 180? Because they're supplementary. So I write definition of supplementary angles. Well, if 5 and 6 add up to 180, then 6 and 7 should add up to 180. Now I'm going to be really, really cheesy about this because it's going to make your life easier. I'm going to write it like this. Watch me. Tim hates me for that, right? He's like, why would I do that? Y'all don't does anybody see the future? Why I would do that? What's that? So I don't have to switch it later? But so if I don't have to switch it later, what are you implying that I'm about to do? You know? Okay. Well, you're right. You're exactly right. So I don't have to switch it later. You still love me? A little bit? Okay, so here's what we have. They are supplementary, and because they're supplementary, you know they add up to 180. And then this is like probably the most complicated step of the whole proof. Shall I give you a hint? Do you want the statement or do you want the reason? Or do you want to do it yourself?
Do it ourselves.
Okay, be independent. Are you want to guess at what the statement is, or do you want to guess at what the reason is? It's hard to guess the reason without the statement, though, right? We learned this yesterday. It's either that R rule, that S rule, or that T rule. It is the transitive property. I'm about to use the transitive property to state if 5 plus 6 equals 180, and 180 equals 6 plus 7, then I can say if it's repeated, it's deleted. So do I need the 180 statement in the middle now? If this equals 180 and 180 equals that, I can say this equals that. So that's the transitive property. Angle 5 plus angle 6 is now equal to angle 6 plus angle 7. That's using the transitive property. Whoa, right? That's a huge leap. That's something that you guys may have not noticed for yourself. So the transitive property says if it's repeated, it's deleted. And we're going to put the transitive property. And it should get a little, maybe more user-friendly at this point, right, Tom? Right? A little more user-friendly here. So can anybody kind of justify what the next step should look like? Anybody? What are we trying to prove? 5 and 7. So do we have that yet, or what can we like?
I mean, kinda.
So that is the next statement. Angle 5 equals angle 7. How did we get there? So you're saying what do you call that deleted word in math when you delete something? Subtraction. I subtracted angle 6 from both sides. So I took away the same thing from both sides, the equal sign. That's called the subtraction property. I subtracted 6 from both sides. Did we do it? We're done? No. So and here's a good thing to look at. Does this say this? I can make it say that. Angle 5 is congruent to angle 7. Yeah, but what's the reason? Huh? Well, I have to justify why it's true.
Because they both 6.
No, they don't both equal 6. 5 and 6 are not equal, they're supplementary.
Because. Write the first letter out.
Definition of. Yes!
Let's go.
Guys, if they're congruent, are they equal?
Yes.
Yes. So I can change it from an equality statement to a congruent statement because the definition of congruent says everything that is congruent is equal.
Yep. It's pretty easy.
That's not bad, right?
Pretty basic stuff here.
Basic, super simple. Now, no one ever told me this, and I hated all my teachers for never telling me this. I'm about to do something that you're going to hate me for, right? I'm going to embrace the hate because it's super important. Let's do this proof again. We're going to do the same exact proof one more time.
I don't have room.
You have plenty of room. Because look,
Where? I've already hit the bottom.
now it's a two-step proof.
Okay.
You're like, what?
Why do we not just
Because that is, Tim, that is super important. Did you ever know that vertical angles were congruent? No, you didn't. If I say, why are vertical angles congruent? What's the reason vertical angles are congruent? No, you would have to say, this is why. right? Did we go through that whole process and prove it? It is factually, it is a 100% facts right now. There is no disputing that vertical angles are congruent now. So now we have the ability to do this proof in 2 steps. Angle 5, what is going on with this? Angle 5 and angle 7 are vertical angles given. And then you can do this now. Now you can do this.
So in order to be able to do the 2-step one, we have to do all the other.
Because the vertical angle theorem says they're congruent. Isn't that crazy?
It's like we could have just
So you just earned the ability to say the vertical angle theorem. So if you ever see something in your life that says, are these 2 angles congruent? You'd be like, yeah, bro, the vertical angle theorem says that. I like to say VAT, vertical angle theorem. So now forever and for always, you can just say, I know they're congruent because the vertical angle theorem says they are. Just like the definition of supplementary. You know supplementary is 180. You know linear pairs add up to 2 supplementary angles, right? Now you can say, I know vertical angles are congruent. So this is the most important part of today. Vertical angles are congruent. Because you're going to see something like this on your test. Does that scare anybody? How would you solve for x there? I think I might. That one's a little tougher. How about? What is going on?
Whoa, what is
How would you solve for that? What do you know about those 2 angles? They're equal to each other. The vertical angle theorem says they are equal. So it's your job to solve for x. -6 on both sides. That was part of our algebraic reasoning. Right, whatever x equals?
28.
28, did you calculate that? Dude, I'm getting so frustrated with this. Do that in your head? 28.
So
Don't make it more complicated than it is, right?
Times 28 plus 6.
no, I know that.
What?
If we know it equals 9 degrees, why can't we just put 9 degrees?
Because I'm not asking for the measure of the angle. I'm cool, I know that this angle is 90, but I want to know how big x is. Right? Does that make sense? Because in this scenario, can you say, oh yeah, 75 degrees? Can you just make something up? You can if you want to get it wrong, that's fine. So in this scenario, how do you figure out the value of x? What do you know about those 2 angles? They are equal to each other. So you have to math 3x minus 40 equals 2x minus 10. You can do that in the calculator. I'm not going to show you that today because this is a math class. If you know that, you know it. But how do you, there are so many different ways to start this. What would you do?
Plus 10.
You would do plus 10
Yeah.
on both sides?
Wait, I would do plus 40, never mind.
Too late. That's actually a really good first step.
What, minus 10?
3x, negative 40 plus 10 is negative 30.
That's not meant to do.
Oh, maybe it wasn't a good step.
It's
It's alright, it still works. Now what? Now that you move all the numbers to the left, you have to move all the x's to the right. So minus 3x on both sides. So x is 30. Alright, so let's plug it back in. 3 times 30 is 90. 90 minus 40 is... Man, what should I get over here if I get it right? Should get 50. 2 times 30 is 60. 60 minus 10. Now on your test, there's going to be a y right here. It's going to say solve for y degrees.
Okay.
Silence.
Well, we know that those are 50,
Yes.
so.
Huh? It cannot be 50.
Not 50.
I cannot tell you how important that is. It cannot be 50. Perfect. We just said that these two angles should add up to how much?
180.
Because they're a linear pair.
Yeah.
So if both of those angles add up to 180, how big is y?
130.
And then it might even go crazy and put like z degrees right here.
Alright, that's.
Why?
Because they're.
Because they're vertical angles. So this one's 130.
That's crazy.
It's crazy, right? And if you add all those together, it makes 360 degrees, one big old circle. Awesome, isn't it? So, on your test, they're going to give you something like this and ask you to solve for x. But it is multiple choice. So, could you plug x's in until you get two equal angles? All day, every day.
Pretty easy, simple stuff right there.
What do you know about those two angles?
They're equal.
That they're equal. That is the only geometry concept I'm teaching. Those two angles are equal to each other. Once you set that up, the rest of it's algebra. Use your calculator or use your hand and solve it.
I'm gonna use my head.
Let's end with this one. So, substantially longer than your test, but your test kind of looks like this. Most of the statements are given, and you have to kind of generate a few reasons on the other side. So AC equals 13, and the measurement of line segment BC equals 3. Given. Is it?
Yeah, it's always given.
Where?
Oh, bruh. I never mind.
Can we put given there? Yes, you can. But it's given over here. You see it? AC is 13 and BC is 3, so it is given.
I was right.
But you have to know where it's given. Then they say that AC is equal to AB plus BC. What are you adding though?
No. AB. Is good.
What is the geometric name of the things that you're adding together?
Angle addition.
Are you adding angles together?
I mean, line
Addition.
addition.
Something postulated.
There's no
Segment addition postulate. Now, luckily for you, all these are multiple choice, and it'll have all the reasons written in order. You have to just match them, which reasons work. And they say that 13 is equal to AB plus 3. What do you call it when you take geometry out and you put numbers in?
Substitution.
Substitution. And then all of a sudden AB equals 10. The subtraction property, I took minus 3 on this side and minus 3 on this side. Now I have AB equals 10. Because 13 minus 3 is 10. That's called the subtraction property. Why is line segment AB congruent to line segment FG and line segment AC is congruent to line segment EG?
Would it be the transitive now, right?
It's not congruent.
You're making this too complicated. Given. Y'all see that?
Yeah.
It's written right here. They wrote it right here. Given. So you can put your given steps wherever you want. Now what is it then? That's given too?
No.
How do you
Is the next
switch?
one segment?
How do you switch from congruence to equality? What are congruent things? They're also called what? If it's congruent, it's also
Supplement.
equal. So how do I switch from congruence to equality? Because the definition of congruence says if they're congruent, then they are equal. This one's weird.
Is there gonna be something like this?
What, on your test? That there will be substantially less blanks. Might be like one blank over here, one blank down here, and then two blanks over here.
I know why it's branched.
So it says that AB is 10, and AB and FG are equal, so why is FG equal to 10?
Because
I took this out, and I put a 10 in. What's it called when you take
subtraction.
substitution? So I substituted that stuff. Substitution. AC is 13, so now EG is 13 because AC and EG are equal. Why is this true? Yeah, well, they say that the first part plus the second part equals the whole thing, and this one says the first part plus the second part equals the whole thing. It's still the segment addition postulate. Taking geometry out, putting numbers in. Substitution. Math occurs. 13 equals EF plus 10. Subtraction. It will never be that complicated on your test. That's just me helping you guys practice. So at this point, right, this is your last day to kind of work on that 2-5-2-6 homework that had all 6 things in there. I'm gonna skip number 5. You can take number 5 and you can skip that one. I don't like it. It's a really stupid proof. So you can skip that one. I am going to give you guys the review a day early. Right, and it's not a long review, but because there's so much writing on here, look at this thing. Yeah, so like the first one is just like identify the hypothesis of the statement, write the converse, write the inverse, you know, like just writing some stuff, and then you'll see. This is what kind of your proof looks like. Everything's there and it's multiple choice, match the reason to the statement. So you don't have to really think of anything for yourself, just to kind of pull from this side and put it over here. And then there's a couple of like mathy questions towards the end.
And that's due on the day